Did I give you this yet?
No.
I should probably do that. Except I'm not giving you one. You can write on line paper one. If my sheets don't have good enough spelling for you. Have I never told you about the time I took away chairs from certain of my students in my grade 11 university class? Yeah. I just decided I wasn't happy with their performance. They didn't get chairs anymore. When they did better, they could have the chairs.
I'm all right.
No, so this was at South Lincoln. I had a class, they were showing up late all the time. And so I started, as soon as the bell rang, we would take all the empty chairs in the room and put them all in the science office and lock it. And if you were late, you stood. And that was that. Yeah. And precisely. But yeah, absolutely.
Did anybody say Marius' aria?
No.
I would have.
I know you would have. And it would have. Okay. Okay, so again, today we'll be review. We're talking in this unit about powers. What is a power? If you wanted to sing, since it seems to be a thing, to, voices is a thing today, you could do like the Power Rangers theme song. I didn't ask you. That was very good though. Has anyone seen that? That looks pretty terrible. Did you see it?
I've seen it.
Is it terrible?
It was actually good for like having no expectations. It was good for no expectations.
Fair enough. All right, I can take that.
It wasn't as good as Go Power Rangers, but the song wasn't it.
Oh, really? Wow. Did I not give you sheets? Well, there's a message in there. I'll let you decode it. We're talking about powers. What is a power? What does that word mean? Like Spider-Man. Now, he built that. Yeah. He built that. Yeah, he built that. But he has the power of being a great scientist. So that's a power. Yes? Sure. I'm more thinking math, though, yes.
It makes, if something's a power, it makes whatever it's giving the power to multiply it by that much. Very good.
So a power is repeated multiplications. All right? Yeah, sure. Of course. So we use powers to do repeated multiplication. Keeping in mind that multiplication is really just repeated what? Yeah, it's just repeated addition. If I say 6 times 2, that just means 6 plus 6. If I say 6 times 3, that just means 6 plus 6 plus 6. When we talk about powers, now 6 to the exponent 3 wouldn't be 6 plus 6 plus 6. It would be 6 times 6 times 6. If we went all the way down to the addition, that would mean 6 plus 6 plus 6 plus 6 plus 6 plus 6 plus 6, 36 times. It'd be big and long. So we're not going to do that. So why do we use powers?
People are too lazy to write it out.
I'm going to argue they're not lazy. I'm going to say it's much more efficient, right? They're being parsimonious. Obviously, we use multiplication because we run out of fingers pretty quick if we try to do everything with addition, right? We use exponents because once we start doing lots of multiplication, again, numbers get very big if we don't have a way to deal with them succinctly. So the parts of a power, I'm just going to pick random letters. I'm going to say A times B to the exponent C. So I'm just going to do kind of a general form over there. And then I'm also going to give you just a real example. What do we call this letter C or this number 2 in a power? What part of it is that? Yeah, that's the exponent. What do we call the number that the exponent is touching? What do we call the number? So this is B to the exponent C. That one is X to the exponent 2. What do we call that first thing? This thing down on the bottom. What's that called? It is, in this case, it's a variable. It won't always be a variable. The base. Good. So in these cases, it happened to be a variable, but that could have been 3 times 4 to the power of 2, right? And what do we call a happy little number sitting in front that is not being put to that exponent, but is being multiplied by the power? That is a word that you probably have used, and it's a good description. There's a slightly more technical term we use. Though again, it's a good word. I like multiply, but coefficient. Good. Coefficient. And the 3 is also a coefficient. I'm not going to muddy up my page by trying to get an arrow there neatly. Oh, hell, yes, I am. Okay. I regret nothing. There we go. Good. I regret it a little bit, but okay, I'm leaving it. Okay, so we got the vocab. We know what to do with it. I just want to review the rules that you should have known a long time with this. If you know them, great. If you don't, we're learning them now. So first things first, adding powers. If I have 3x cubed and 5 squared x's, can I add those together? And if so, what do I do?
When you add the coefficients and then add the exponents.
Is that true? Okay. In fact, you're outsmarting yourself because we've made this lesson about exponents. Because if I had done this yesterday, when we were still in our polynomial-based unit of transforming functions, if I told you to simplify this, could you? No, because you can't. What's the term we normally use for this? I mean, here I'm calling it adding powers, but what are we really doing here? I could factor it. That's true. I could factor x's out. Yeah, when we collect like terms, we're adding powers. And what's the rule for collecting like terms? They have to be? Yeah, they have to be like. They have to be similar. So are these similar? No. I can't add these because even though the bases are the same, the exponents are different. So I can't add these. All right, and the rule, I'm not going to write it by hand because I already wrote it above. When we add powers, we can only do so if the variables and the exponents are identical. Not the coefficient, but the variables and the exponents have to be identical. And in this case, these are conspicuously not identical. If I had a pair of identical twins in the class, we could play a brief game of identical or not identical. But seeing as I don't, we'll move on. You guys look very, very similar. You could probably collect you as like terms. Okay. Now, what about these happy travelers? Yeah, these are like terms. They have the same base, and the same exponent. So in this case, what can I now do with these? Yeah, we add the coefficient. So what would the answer be? 8x cubed. Good. Now, what did not change here? Yeah. That's right. We are adding. What's the only way you can change an exponent? Multiplying, right? Exponents are repeated multiplication. Exponents tell you how much multiplying to do. So if all we're doing is adding and subtracting, you're never going to change an exponent. Does that make sense? So this rule, it's almost a shame we wrote it down because I know you know how to do it because we just did a whole unit where you had to collect like terms all the time and you guys did very well with it for the most part, right? The odd time you'd make a little mistake collecting like terms, but mostly you did great. And you know the rule. You know that you can only add powers if the variable, if the base, and the exponent are identical. And really, this should say bases. I said variables, but that was a sloppy use of language on my part. Happens to be true in this case, but this would work just as well if it were not a variable. Let me show you what I mean. If I had 7 to the exponent 8 plus 7 to the exponent 8, or yeah, I would now have how many 7 to the exponent 8s? No, I would have 2 of them. I would have 2 times 7 to the exponent 8. I can't change the base. I can't change the exponent, right? The only thing I could do is say I have 2 of them. that make sense? I'd have to put a coefficient in front. We don't do this with numbers often, right? 2 times 7 to the exponent 8 is clunky. We would more often than not just evaluate this, right? But I could do it. I can collect those as a like term. But I have to keep in mind that I can't change the base. I can't change the exponent. The only thing I can change is the coefficient. So if I have a 7 to the exponent 8, I've got one of them, and Dana with an I has 1 7 to the exponent 8. Then between us, we have 2 7 to the exponent 8. Does that make sense? It doesn't have to be a variable. This is true for any base. Yes, ma'am? You could, yeah. I mean, if you wanted to, you could say, let 7 equal b, and then you could call this b to the exponent 8 plus b to the exponent 8, and have it be 2b to the exponent 8. Sure, nothing stopping you from doing that. Again, I question why we would do that, but you absolutely could. That's good math. That works. I'm going to erase it because it's not kind of what I dreamed of being in this note, and I'm going to erase this because it's not really what I dreamed of being in this note. If you put it down, that's great. It's fine. Nothing wrong with it. Just when people come look at these later on when they're online, the less clutter, the easier it is to follow. Okay. Now, multiplying powers. I already put the rule up there, so you might as well read it. Not hiding anything here. When we multiply powers, we add exponents. Why does that work? Let's think of it this way. If I have d squared times d to the exponent 3. Well, the answer is d to the 5, right? But let's show why it works. I will never ask you to show this again. Let's make sure we have it cemented. What does d squared equal? What's that really mean? d times d. Oh, I'll highlight that. And what does d cubed really mean? That's right. Times, and then this is d times d times d. And all together, that is d to the exponent 5. This is why it works. Now, are we going to draw that out every single time we do a question? No. It would be preposterous to do so. So what we say is if we have x to the exponent m times x to the exponent n, the bases have to be the same. We can do what with the exponents? Add them. No, it would not be xmn, because that wouldn't be adding them. That would be multiplying them, which we do not do. This is not d to the exponent 6. D to the exponent 5. Okay, so why don't you try the 2 examples below? Yeah. What do you, they're just numbers. So what's 2 times 3? Yeah, you know that. So don't
want to know if you added or subtracted.
Well, what's the symbol telling you to do with them? Like, I'm not trying to be snarky, but that's the question you ask yourself. What is this symbol telling me to do with that 2 and that 3? It's telling me to multiply. Yep, but here's why we add the exponents. Because d squared means d times d, and we're still multiplying, times d cubed is d times d times d. So that's all multiplication. Why do we add the exponents? Because now there's 5 d's, which is because we had 2 d's and 3 d's. So we add the exponents because of the way it works out when we multiply. The actual question is all multiplication. The thing where we add exponents, that's a trick. That's an algorithm. It's just something we do to make it easier for ourselves, because otherwise we'd have to write it out like this, but the coefficients still just get multiplied. And that's a great question, by the way. It's exactly the right question to be asking. No, so it didn't sound that way. I've been told that I have a sarcastic sounding voice in the best of times. No, that was sincerely a really good question. You're way ahead of me? Oh, good. Good to be. I'm not too hard to be way ahead of. That's okay. So using this rule, x cubed times x squared.
6x to the exponent 3, y to the exponent 3.
Oh, this one first.
Oh.
Sorry. What was she saying to me? Yeah, this one first. How do you get the answer? Obviously, the answer is great. And how'd you get that? X to the exponent. Yeah, x to the exponent 3 plus 2 equals x to the exponent 5. Very good. Good job. Okay, now we're ready for you. Sorry. Way too quick for me there. What'd you get over here? Yeah. Now where'd that 6 come from? 2 times 3. Good. What next? X. And I will never expect you to show this, but I'm going to show the work here. How'd you get that? X squared plus. That's right. If there's no exponent written, we know there's just one of them. And then the y's, how many in the first one? And in the second one? Very good. And now that gives us the answer. Very good. 6x cubed, y cubed. Again, do I expect my grade 9s to show that middle step? Of course I do. Do I expect you to show that middle step? I do not. But I want to show it to make sure it's clear. Now then, if multiplying lets us add the exponents, when we divide, we subtract. Let's look at y. Let's do d to the exponent 3 divided by d to the exponent 2. Let's do that. What does d to the exponent 3 actually look like? D times d times d. What does d squared actually look like? D times d. Very good. Now, if we look at this, why I did that all in red, I don't know. But this d divided by that d would be what? What's d divided by d? Not 0, but 1. Good. They cancel one another out, leaving 2 d's on top, 1 d on the bottom. But this d divided by that d, that's going to equal 1, leaving us with just what? Just the 1 on the top, 1 on the bottom, and yeah, and yeah, that's right. Sorry, I was just having fun. So d to the exponent 1, and normally we wouldn't write that exponent 1, but I'll prove the point. Which means that as a rule of thumb, when we have x to the exponent m divided by x to the exponent n, what do we get? Very good. Very good. And by the way, just like last time, when you get to coefficients, what's the logical question we want to ask ourselves? I suppose. What's the other question we're going to want to ask when we get to coefficients? Like when we get to this question? Yeah, and I very cleverly picked a question where both give you the same answer. That was stupid. But that's okay. Which is it? Do we divide or do we subtract? Coefficients. Very good. Yeah, the coefficients we just do very normal math with. Very good. It's the exponents that we add and subtract. It's like, again, I keep coming back to teaching grade 9, just because they're new to like a lot of the algebra stuff, right? So they will often use minus or subtract just awkwardly. Like if you have like -5 plus 2, they'll say like -5 plus 2 or like subtract 5. You know what I mean? They use the language kind of awkwardly. And then I find that sometimes I want to correct them, but sometimes it's more important to me that the math is good. It's good, so I'll just use the same language they're using, so I'm not confusing them, because it doesn't seem like I'm correcting them. Like I just want them to be like, yes, what you're doing is good, keep going. But then you start using kind of awkward language yourself, and then you find like, now I come teach a grade 11 class, and sometimes I'll say something really sort of a little differently than I normally would, and I think, oh, I sound like a grade 9 student. Yeah, but exactly, right? But that's anyway, so this question here, what are we going to get? X to the 5th divided by x squared. And how'd you get there? You're totally right, of course.
5x is 5.
Hi, how you doing?
Jinx. I said, how you doing? And you said, how you doing? And then
We didn't say it at the same time.
yeah, you did. You told me you did.
No, we didn't.
Yeah, then how?
I'm not convinced you know how jinxing works.
I heard you say it the same time as I did.
You're like one of those like 9/11 conspiracy types. It's not going to matter what I say to you, so we'll just move on. You're probably right. I'm deaf. I'm very deaf. I don't know. My sister would always punch me, but I don't think that's in the official rules. I think she was just a physically violent person. All right. And what about this fine fellow over here? 4x cubed divided by 2x. And talk me through it. Yeah. Very good. And I'm actually going to show the thinking here. We do like 4 divided by 2 to get the number, right? And then to get the exponent, we do. Very good. And 4 divided by 2 is? And 3 minus 1 is? 2. Very good. Does that make sense? Let me kind of show that here since I can do examples. I'm sure I could. I didn't follow what you said because I'm not clever enough, but I'm sure it was true, and we'll move on. Okay, so we are almost done, which is nice. So I want to look at another example. Let's suppose that I had x cubed squared. X cubed squared plus x cubed squared. So we have x cubed squared. So what do I do with that? What does it mean to square something?
When you square something, you're times it by itself.
You're multiplying it by yourself. So x cubed squared would mean x cubed
Times x cubed.
Very good. So that would mean this is x cubed times x cubed. Now, we know our exponent rules for multiplying. When I multiply 2 powers, what do I do with those exponents? Very good. We add the exponent. So the answer to this would be x to the exponent. Very good. Now here's my question. Could I have used these 2 numbers to produce this number? If so, how? How could I have, without having to draw this middle step, because that worked nicely that this was squared, but if this was to the exponent 27, we can agree that this would become this. Yeah, we'll multiply these 2 numbers. So the rule is, when 1 power is put to an exponent, we multiply the exponent outside the bracket by the exponents inside the bracket. And I gave a bunch of different examples below that all follow kind of different cases, but they all follow the same basic rules. So take a minute, do those, and I will walk around and say things like, good, that's the idea, or kind of, don't forget this, or drama. Always thought you had dramatic tendencies. Something like that. No, I don't know how to do it, guys. Maybe not. No. I had a chemistry professor once offer to pass me the class if I promised to take an organic chemistry class again. I took her off of them. And then I didn't keep my own voting, so I kept taking it. And did pretty well. That one, no, she was a super student. I did both of them for 7 years. Good. 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 Well done. Yes. 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 Well done.
Hugh. Oh. Hugh.
Yeah. Good job. Yes. On the inside. I did, yeah. That's my, what are those things I have? Feeling. So, yeah. I used to when this one came around. Now I've pushed them all in. You replace them with. No, that's a feeling too, right? Just crushed indifference.
Can't be
Do they not teach cursive anymore? So when I write all my notes in cursive on your test, do those just get ignored then?
No, I
That's
can
probably
read
something
it.
I
I
should
just
say.
can't write it.
Oh, okay. Well, that's good. What do we do?
I don't like it. It looks like aqua. Don't worry about it. As long as it's next to a U, you'll know.
Hey. All right. So obviously, really quickly, here the x gets, the exponent is 2 times 3. Oh, that's red. Which gives us x to the exponent. Good. Here it gives us what? Yep. Yeah, I'm just going to put the answer at this point, if that's okay with everybody. So we do it to each base. What about here? Yes, ma'am. Yep. Very good. And what about over here? Alondra, I'm only kidding. I'm not going to pick on you on the question you don't know. But what'd you draw? Hold it up. Let's let everyone see. I like it. It's really cute. Trina. Okay. Very good. So just like here, we just take every letter and we multiply the exponent by the exponent. The fact that it's on the bottom of a fraction, what we do with it. The process is the same. Good.
Is it okay that I put it like this because brackets then exponents? Because I put it x6.
That's different. So you're now multiplying. It's got to be, because you say brackets first, but like you can't do that in the bracket. X divided by y, you can't simplify that. Right? Does that make sense? If it were x divided by x, then it would just be, you know what I mean? It would cancel. But it's got to be a fraction. Does that make sense? Okay, now here's what I want to ask you. I want you to see if you as an individual, maybe as a group, can come up with... Shh. If you can come up with a situation using the rules we know already where you might get a negative exponent. Oh, I had one job. I was going to throw that right at you. And I failed miserably. Thank you for setting me up, though. I really was. I was going to send it right at you. And the only thing that stopped me was my own incredible clumsiness and awkwardness.
I was like, great, that's so hard hitting that. Are you trying to hit me with a bluff?
I intentionally missed you with that one.
Okay.
That one was coming your way.
There's a stapler. Yeah, you can try and kill me again.
I don't know. What's it say?
Shut out impaired driving.
So are you complaining about that
What
message?
Yeah, but why throw something at me and drop it? You dropped it.
I was trying to throw it at her. So that's about.
It's an impaired driving test. You can catch it, you can
Is that
drive.
supposed to be a free hockey puck or
Yes,
something?
yeah.
Why does it say that on the hockey puck?
Okay, you know,
Because,
I feel
whenever
like
I
I feel like we're done, but it's a very weak pun, like shutout impaired driving. Like a shutout is when a goalie doesn't let any goals in.
Well, what if you don't play
just
hockey?
did.
You don't even know what that is.
So-
Literally, let's
Same.
Literally over everybody's head.
Why do they say you like break away?
That would have been more positive.
Because like,
Or like score a goal for sobriety. Like, I don't know. Yeah, I don't know. I don't know what to tell you. This is why I could never be like the person behind these ad campaigns, because I am bereft of good ideas. So I want you to, using the rules we know, give me a situation, give me a type of question on your page where you would have a question that would give you a negative exponent as the answer. Could that happen with the rules we know so far? Look back at the rules we know. In part 2, adding powers, we didn't change the exponents, so that can't do it. In multiplying powers, we did what to the exponents? Added them, so that's not going to do it. In dividing powers, we
Subtract.
that's probably where you're going to get the most bang for your buck there. So let's see what we can do. Can you make a question that gives us a negative exponent as the answer?
Pretty sure
I did. I did already.
Well, if you say no, you're gonna get a hockey puck.
Not only did you do great, you did the same one.
No.
I.
No.
Cheater. I did this while we were still doing number 4.
How? I
I did while doing number 4.
Funny.
I'm
Funny or
for
you're
copycat. I'll sue you. Sue you.
I'm all on.
I guess.
I do it writing the same way. And how could I see? I can't even read it.
Oh, no. You like my list of colors? Like,
This is
what's
gonna
happening
find
with
the
the sides, it's not happening.
Me right now.
I didn't know there was any cat in the first place.
Blue.
Hey.
Oh.
Down here.
Well, that, it was not in
That's good. That's good.
You know what? I didn't
Well, this one, you
All
need
right.
to- The x has what exponent? And we multiply it by, which will make it. Now, make a fraction, just like what- on the bottom, what is the y?
The beer store supports
Why is that even?
not drinking and driving.
Like, it occurs to me, I threw it at Alex the other day, but that doesn't answer the question where it came from. Yes, sir. Okay, just a few points. First, you don't get wine at the beer store. Secondly,
No, you get wine at a wine shop, like at Zares.
Secondly, I drink
Yeah,
very sparsely. Thirdly,
I've been in there a couple times.
I don't mark in my car while driving either, which I think would also be unsafe. So that's
The beer
There was-
store
it was
supports not
11
drinking and
a.m. and
driving.
I was going to get my
Meanwhile, they sell
coffee.
beer.
Not my
literally, the beer store basically only sells beer. It's like called the-
yes, and
We're
apparently
actually in that coffee. First, the LCBO was like every time I got the call.
I don't care for you telling me.
He's a very
All right, so
Not moonshine. Nowhere moonshine.
okay, I did. That was a good pun. It was very well done. I saw one that I liked. I mean, they were all good. You all did very well. But I like this one. Oh, did I say I liked this one? I said I picked the worst one that I liked least. No, I like this one. It's good. It's a good choice. Okay. Now, if I were to put this, first of all, we know the rule tells us that this will be x to the 2 minus 6, which means that this will be x to the negative 4. But I want to pause for a minute. Let's think about what this really means. X squared over x to the exponent 6, if I were to write it out in full, would look like what? would it look like? What would the top look like? Very good. X times X. What would the bottom look like? Very good. 3, 4, 5 of them, 6 of them. There we go. Now, if I get canceling, this X will divide by that X, and they will both leave us with 1. This X will divide by that X, and it will leave us with 1. So I'm left with 1 times 1 over 1 times 1 times X times X times X times X. So I'm left with what? What on top? 1. What on the bottom? 4? 4X? Yeah, you got it. Very good. Does that make sense? Well, wait a minute. This is a conundrum, because on the left, it tells me that x squared divided by x to the 6th equals x to the exponent -4. But over here, I did the same question. I also did good math. And now I'm being told it equals 1 over x to the 4th. Well, Euclid's first axiom. Anyone? Euclid's first axiom. In his famous publication, Principia Geometrica, Euclid said that two things that are equal to the same thing must be equal to, yes, so they must also be equal to each other. This is Euclid's first axiom. If this variable over here equals 12, and this variable over here equals 12, those two variables must equal each other. Abraham Lincoln used this in his written defense of the Emancipation Proclamation. That if men are created equal in the eyes of God, then they must be equal to one another. But it is Euclid's first axiom that two things that are equal to the same thing are equal to one another. So if x to the -4 equals this fraction, and 1 over x to the 4 is equal to this fraction, then they must be equal to each other. Good. So x to the -4 must equal 1 over x to the 4. So if we have a negative exponent and we want to make it positive, what does this rule here, what does this thing we just did tell us that we can do with that negative exponent? Yeah, I can make it a positive exponent. I can flip the sign if I also flip the base. I have to invert the base. And inverting means flipping the fraction, right? When we did division by fractions, we talked about inverting and multiplying. Remember that? No, you did, because y'all did a good job with it on your test. Did I just say y'all? God, I'm so folksy. So here's the rule of thumb. Trash. That's a little harsh. So if I have a over b to the exponent -c, and I want to make that exponent positive, what can I do? What did I have to do to the base? Yeah, so what would my new fraction be? Yeah, very good. B over a, and now it would be to the positive c. So try to apply that to the 3 examples below. I tried to make them sneaky. Not the first one. The first one is distinctly not sneaky. Or the second one, I guess. That third one is sneaky. Anything that y? Is that exponent for anything that y? Yeah, that exponent isn't even touching it, so you can only do it less. It would. It would. Now that is bad form to have a fraction in a fraction. So it's okay. So what we would normally then say is This can flip. Yeah, this is no problem. That's okay. So we could say, if you have a fraction, 1 over x squared, divided by 1. We can never do this. How do we do division of fractions? It's like a fraction. Now, you take them along with it. That's good. Because your long way explains exactly why. Having said that, we look at the sum. It means
I think you're the hand, but
the way you did it actually shows why it works. But long story short.
I was planning on watching it in my break, and I was planning on watching it Saturday. I didn't really do it.
Not back, my knees. You know, this thing happens where you get a little older, and then you get a little heavier, but you don't. But it doesn't carry with it like a matching like gain in strength. So you just have the same strength you've always had, but now everything weighs more, right? I mean, so simple physics tells you that you're working a lot harder, right? Yeah. Anyway, that's the end of my story. Well, you know, the fickle finger of metabolism does not make that the case. In fact, what percentage of your energy, you know, let's say you're supposed to eat 2,000 calories a day, even for an athlete, let's pick like a real top athlete who does a lot of physical activity. Yeah, precisely. What percentage of that person's dietary caloric intake is spent like moving around and doing sports and with physical activity? Yeah. Well, except most people eating 3,000 calories are not, unfortunately, they're not using that. Now, luckily, your metabolism just sloughs some of that off. It just, you know, gets rid of it, which is nice. It just is inefficient. But there's only about 10 to 20%, 20% an absolute max of your energy that gets used, even if you like exercise all day, every day. The overwhelming majority of the energy you put in your body is just used for, yeah, like just your heart beating, your lungs lunging, your, you know, intercostal muscles, intercostaling muscularly, your diaphragm, shall we say, diaphragming. I don't know. You know, all this science stuff that I guess I do actually know a fair bit about. But the point being, so, you know, that's the sad thing about the exercise approach to weight loss is it cannot, it is at best a 20% return on investment. Exercise is like the most important thing in the world for all kinds of things. It's very important for your health. Not an effective way to lose weight. Not an effective way to lose weight. In fact, what the science overwhelmingly shows us is there aren't really very effective ways to lose weight. That was yeah, that was yeah. I didn't care for that. Yeah, that's I found that distasteful. I like to be the person saying distasteful things, but that's okay. I guess everyone gets one. So anyway, yeah. Anyway, that is all apropos of nothing. But there you go. Long story short, when I have to kneel down to help students, it's always a question of, is this where I die? Is this where I'm never seen again? Is this the untimely end of Joe? Hasn't happened yet, but one of these days. All right, this exponent, what do we get? 1 over x cubed. Good. 1 over x cubed. And what would this one give us? Y over x, and to the exponent 1. And obviously, do I need to worry? Do I need to worry about? Does anyone else's keyboard randomly switch to the other keyboard type? Did you know? So this has bothered me forever, and it makes me so angry. Do you know that if you hold Control and Shift at the same time, it switches between them, and that's why it happens randomly?
Oh, yeah.
I did not know this until like 3 days ago when somebody told me, a student told me, and it changed my life. Because you know when you're at home and you're like, why is it doing this? And then you got to find the thing and click and change. Control and Shift together. Now, for the record, that's still a terrible feature that the keyboard should not have. But at least now I know how to undo it. Do we need to write an exponent of 1? Of course not. So we shall write that just like that. And lastly, this one, this sneaky one. That -2 is affecting what? The x. Is it affecting the y? So when I flip this, when I invert the base I am inverting is the x. So the x is going to go from the numerator to the denominator. That's intuitive. But the y is not a part of that exponent. So it is going to stay right where it bloody well is. It's going to stay right there. What goes on top then?
1.
Yeah, that most universal of placeholders, 1.
How about the other way of doing it?
My mind just flew.
Yeah.
No.
That's the way of doing it. My way.
Your way was excellent. It was good. It clarified it. It really did. I just don't want to go down the rabbit hole. It was good. It was good math. I liked it. It was a good illustrative example. But I'm being, this is, I'm just treating this as a pronouncement. Like, just do it this way. Are you disappointed in me? Really? Okay, I'll show you, because Londa's math is good. Let me show you what she did. She said, really what should happen is on the top, we should end up with 1 over x squared over y, which is true. That would be following the rule exactly, right? We would invert the x squared, put it on the bottom. Now, of course, we don't like a fraction over a fraction. That's poor manners. So a fraction really means what operation? Division. So I could say that this is really like 1 over x squared divided by y. Now, when we have fractions, how do we do division? We have to do what to the second term? Invert it, and the operation becomes multiplication. So this would be 1 over x squared times 1 over y, and that would, of course, equal numerator times numerator. 1 times 1 is 1, and x squared times y is x squared y. So that was Alondra's approach, which is a better approach, just to be clear. That absolutely algebraically shows why we do what we do. Having said that, are you going to do that every time?
Yes.
I will look forward to it. You're going to need to be like Andrew then and staple pages of work to your tests, which is fine, by the way. It was very easy to follow.
Was that annoying for you, though?
No, it's fine. That's what I get paid to do. It's my job. I like my job.
People like testing them, so you see what the answer
What's
was.
annoying about my job? I get annoyed when people write a test in red pen. Every once in a while, some jerk will do that, and you just feel like not marking it. You just feel like being, oh, you know what I'm going to do? I'm going to get a pencil and put 0 at the top of it. But
I did that a few times.
in crayon. That's what I should do. I should go get my kids crayons. Oh, I like that. Or like macaroni art. I should put all my comments down, very carefully gluing macaroni art together. It would take a long time, but I'd feel good about it. No.
You don't care when you don't care.
I do care. That's my problem. I care. That's. I'm a person. I should mark it all with my non-dominant hand. Like write all my comments with my left hand. Like try and figure out what you got, kid. Good luck. Oh, this is pretty neat. That's
Oh,
not.
do you not like red pen because you still red one on your work a lot? So
You think because one thing happened with the color red, I now hate all red-colored things?
maybe
No. It's because traditionally we use colored pen to mark the test, so it's very hard to mark the test if it's already covered in
That's
colored
probably why
pencil.
they're doing it.
I do.
Well, then what's the problem?
It's still a big wash of colored ink. It's just more complicated. Pencil and colored ink contrast very nicely. It's very easy to keep track of where you are.
You don't like that I use pen.
I don't care for it. I think I find it to be a strange choice.
See, I always had.
I think of it as a very confident choice. It's like, I'm so confident I'm not going to make mistakes. I'm doing my math in pen. I like to imagine that back in the days before pens, some guy did all his math, like just, some people would like do the math in the sand first and then carve it onto the stone. And then like the really, really like, bold, arrogant kids, they'd just like chip it right into the granite first. And then when the teacher came by and was like, well, that's not right, they'd be like, well, damn. And they'd have to go like to the quarry and get like
No,
a,
I have a reason why I always use pen.
Anyway.
And my elementary school teachers don't let me use pens like writing is really messy.
Is it neither with pen? Fair enough. It actually always makes me think. My grandfather was a mathematician. He had a PhD in applied mathematics, and he taught high school math for a bunch of years later on. But he liked it. Listen, teaching high school, you make, I don't know, maybe 30% less than your average professor. It's pretty good.
30% less.
Yeah. And the thing is this, I don't know about other fields. I don't know about other fields, but I do know about science. I don't even want to know.
You're so savage.
Woo!
What?
Are you being unkind?
No, I'm being very kind.
It
was on your like. It was helping. It was.
Sounded a little bit like you're
It was
being
on.
unkind.
I was
All I'm
being
saying
nice
is-
to you,
All I'm saying is
and-
people don't normally laugh like that when she's like, man, she just said something so nice. I'm going to burst into laughter. I've never seen that happen. I don't know what the heck. Anyway, so I don't know anything about what being a math professor would be like, but I know a lot of university science professors because I studied under them. I have a friend who's doing his postdoctoral studies right now and hopes to become an academic. And when you are a university researcher, you have to teach. You teach your classes, and that takes a substantial amount of time. And then they are also expected to do scientific research, which takes a substantial amount of time. They're expected to publish and write, which takes a substantial amount of time. They're expected to take on graduate students and train them to be the next generation of academics, which is a lot of work. And then you spend like your whole life in bureaucracy and meetings, like filling out grant applications to try to get the government to give you, like $25,000 to cure cancer. And it's like, yeah, you can have the money to do life-saving research, but first, take months out of that life-saving research to fill out these papers in triplicate.
I'm like an elementary school teacher, and the kids do everything the same.
Elementary school teacher sounds like the hardest job in the world for me. I would rather be.
I would love to be like.
I would honestly rather be the. I would rather be the guy who taste tested food for the king to see if it was poison, and then when it was, you died. I think I would prefer that job to teaching elementary school.
Oh, you're not the only one
Right?
who said that.
Like you got to think. First of all, the king probably gets pretty delicious food. So eventually you're going to die, but first you're probably eating a lot of good meals. And secondly, and I think this is key, you wouldn't have to teach elementary school, which sounds really hard.
Why? I would love to teach elementary school.
Ew. Right?
You were like,
You were on 6 I don't care how much you think you were.